Are you struggling to understand timer on, timer off, and RTO timers in Studio 5000? You're not alone. These timers can be confusing, but by the end of this video, you will have a clear understanding of how to use them effectively in your projects. So stick around to master these essential tools. Hello and welcome back to ReddyControls YouTube channel. If you're passionate about automation and controls, you have come to the right place. Today we are diving into 3 fundamental timer instructions in Studio 5000. The on delay timer T on, the off delay timer T off, and the retentive timer on. These timers are crucial for precise control and timing in industrial automation. Before we get started, make sure to subscribe to our channel, hit the bell icon for notifications, and share this video with your colleagues. To get most of this tutorial, you will need a basic understanding of ladder logic programming and familiarity with Studio 5000 software. If you are new to these concepts, I recommend checking out our previous videos on ladder logic basics and introduction to Studio 5000. Now let's get started. Right now I am online with a Compact Logic PLC and it is already wired up to 4 lights, as you can see, the green light, yellow and the red light, and the mapping is done here. I have 3 switches connected, input 5, input 6, input 7 connected to switch 1, 2 and 3, and green light, yellow light and red light are wired to corresponding 0, 1 and 2 outputs. So we'll get started with adding a timer on instruction. So we insert new rung by selecting that. Now by going into timer and counter, hit T on, and we will create a timer called timer1_T on. Right click, create new timer on. When you create this timer, it's a data type of timer, create, and once we created the timer, if we enter the tag, that timer file has created a preset which is a decimal style dint, and an accumulator, a dot enable bit, dot timer timing bit, and dot done bit. The preset is the amount of time the timer should count up to, and the timers in Studio 5000 are of base 1 millisecond. So if we want this timer to time 10 seconds, we need to type 10 times 1000, which is 10,000, right? So what this does right now is this: once the input condition is on, the timer will start timing in milliseconds and go all the way to 10,000 milliseconds, and once the 10,000 milliseconds is reached, the timer sets the done flag. So we'll go ahead and to simulate it, we'll go ahead and add a ladder switch, like a selector switch. Create a select switch, and we want to insert one more rung, and we will use timer1T on dot enable bit, and when that dot enable bit is on, we will try to turn on light 1, which is green light, and then when we'll insert one more rung by selecting this, and this time we will use a timer1.tt, timer timing bit, and when timer timing bit is on, we will use light 2, which is the yellow light 2 yellow, and we will add one more rung, and now we will use timer1.done bit, and when this done bit is on, we will turn the light 3, which is a red light. Simple logic here. We'll go ahead and assemble all, finalize all edits. Yes. So right now, initially the timer1 dot enable bit and done bit and timing bit are all low. Now we will turn the selector switch to on. Once that's on, the timer keeps timing. The enable bit is on, the green light is on, and since the timer is timing, the yellow light is on. And once the timer is done, the done bit comes on and the red light comes on. Once the done bit is on, the timer timing goes off. And once we deselect the select switch, everything resets to 0. We will run this again. To begin with, everything is reset. Now we will try to toggle the selector switch. Once the input condition is on, the timer starts timing. Since the timer is enabled, we have the enable is on, the green light is on, and timer timing is on, we have the yellow light. And once the accumulator value reaches to 10,000, which is our preset, the timer done bit goes on and the red light comes on. This is one way of representing the timers, and timers are useful. We use them in a real world application where if you want to have a horn or a siren going on before the machine starts. So if this is a start button, we take the timer timing bit and turn a audible on. So that means if the moment the selector switch is switched to on, we have the audible alarm beeping for 10 seconds, and then the alarm goes off, the audible horn goes off. Now we'll try to represent the same thing visually using a trend. So we will right click trend T on, we will stop the trend and add all the pins. We added the enable, we will add the timer timing, timer 1 underscore T on dot TT, and we will add the dot done. We'll add the preset and we will add the accumulator value. We'll say okay, and we display isolated graphing apply. Now we will run the trend. One thing we want to do is increase the x-axis pen to minutes so we can see. So now we have both the trend. Initially, as you can see, timer 1 is not enabled and enable is 0. The timer timing is not timing, that's 0, and done bit is 0. Preset is at 10,000 and the accumulator is at 0. So now we will toggle the switch. The timer started timing. You could see the timer timing is high and the accumulator is reaching up. So we will, let's make this 15,000 so we can have enough time to see it. So we'll reset, everything is reset. So we will toggle the selector switch, the timer timing comes on, the done bit is low and the accumulator is still trying to reach. Now before it reaches 15 seconds, if we toggle it, the enable bit and the done bit goes slow, which makes all our lights go, and also the accumulator resets to 0. This is the difference between a non-retentive timer and a retentive timer. Timer on delay sets the accumulator value when the input condition goes slow. Now let's switch to the next timer, which is a TOFF timer. To add a TOFF delay timer, we will go ahead and add one here, insert new rung. We will still use the same selector switch, select switch, and we will insert a timer off, and we call this timer 2. Let's go T off, and we will set the preset of this one also to 15,000. We'll use the same logic for test those. We'll just change that to timer 2 T off. Alright, so now initial condition, we will come back and we'll go ahead and change all these to timer 2. So we'll go ahead and remove all this. We added all the necessary bits. We apply, and initially timer 2 off, everything is off. Once selector switch is on, the enable bit and the done bit came on, and the timer timing bit is not high yet because it's waiting for the input condition to go off. Whereas timer timing, the T on bit was T on instruction was a on delay, whereas T off is a off delay. That means when the input condition goes off is when the timer starts timing. Since the input condition is on, the enable bit and done bit are already high and it will not start timing. Once I toggle the selector switch to off position, the timer starts timing. At that time you could see the yellow light coming on and the done bit is on because the signal went low, and once it reaches 15 seconds everything resets to 0 and all the lights become off. We'll try to run it again. This time it's off, everything is off. We will turn the selector switch on. The timer timing for the timer to T off will not start, but the done bit is indicating that the T off instruction picked up the input signal going high. That's why we have a red light on, and you could see that right here where the done bit, the timer to T off done bit came high. Now once the input condition for the T off goes off, the timer 2 starts timing. As you can see, timer 2 is timing and we have a yellow light there and we have a red light because it's the done from the previous one. Before it reaches, if we toggle it, the accumulator value goes to 0 and the timer done bit goes high. Okay, we'll try to see that again. So all it's showing is like, hey, I picked the time T off instruction picked up the input condition being on. So we toggle it. Once the input condition is off, the done bit remained high. And while the timer is timing, if we toggle the input condition back to on, the done bit stays high and the enable bit also goes high. And if we toggle it again, the done bit is high, indicating. So that's the purpose of timer off, is when you want something in the system to stay on for a longer time than everything else of the system. Maybe an exhaust fan, you want it to be on for longer time after the machine stops for proper ventilation and cooling. And the next timer we're going to learn about is Retentive Timer On. The Retentive Timer On behaves exactly the same as a timer on, but it retains the accumulator count. We'll go ahead and add that timer. We will use the selector switch again and we will use Retentive Timer On. This time we'll name it timer 3 RTO. We right click, find new RTO, create new. We make the preset 15,000 and we'll use the same logic for turning the yellow light and the green lights. Right, we will go ahead and assemble all this and delete this so we don't have a duplicate destructive bit. So now we'll go ahead and turn on the selector switch. Once the selector switch is on, as you can see, the enable bit is high and we have the green light on. Oh, sorry, my bad. These should be timer 3 underscore RTO dot enable timer dot timing, and the last one should be timer 3 RTO dot on. Stop the trend and we will run the trend again. So we will toggle the selector switch to off position. And one thing which we saw, the timer accumulator value reached 15 seconds. This is the main difference between timer on and retentive timer, is the retentive timer retains the accumulator count and we need a separate instruction to set the timer. So we'll just add a reset, like a reset push button. We'll create a new tag and insert set and we will reset the timer. We'll go ahead and assemble these. So once we push the reset button, we'll toggle the reset button. That would reset the timer accumulator value. We'll go ahead and set up the trend also for all the timer 3 values. So we'll go ahead and remove all the existing timers we have and existing timer 2s, and then we will add timer 3s. Timer 3 underscore RTO dot enable dot timer timing done dot preset and dot accumulator, say OK, apply, run. Now we'll go ahead and turn the selector switch to toggle on. We will go ahead and toggle. Before we do that, we need to reset, toggle low the reset push button. Now we turn the reset. Now we'll go ahead and select the selector switch. Selector switch is on, the enable bit is high, you could see the green light coming on, and the timer is timing, we have a yellow light. And if we lose the input condition, the accumulator value is retained, it's not reset. Whereas the enable and the done bit are low and we retain the accumulator bit. Once the input condition comes on, the timer will restart at 13,000 and it reaches 15,000. As you can see, the input condition went off at 12,549 and we lost the timer timing bit in here, and it came back up when we started running it again. Again, we'll try to run this one more time. We talk and we turn off the input condition, we push a reset button to reset the timer 3, and we reset the time reset button to low, and we'll run one more time. The timer starts timing, timer 3, the enable bit is high, and once the input condition goes low, the enable bit and the done bit goes low, but the accumulator value is still retained at 10,000. It retains. That's the main difference between a timer on and a timer off. Sorry, timer on and a retentive timer. Once we toggle the selector switch, the RTO comes on and you could see the timer done bit is done and the red light is on. And we could use retentive timers if we had to indicate or track for how long a machine has been running, and we can use the done bit to flash a light so maintenance would go and do any PM since the machine ran for so number of days. That's all for this video. We looked at 3 timers: the on time delay, which is a T on, the off time delay, which is the T off, and a retentive timer on. To summarize, we have covered the basics of the T on, T off, and RTO in Studio 5000, including their setup, configuration, and practical applications. These timers are powerful tools for precise controls in industrial automation, and mastering them will greatly enhance your programming skills. Now it's your turn. Practice setting up a T off and an RTO instruction in Studio 5000 on your own systems. Share your experiences and any questions in the comment. Don't forget to give this video a thumbs up if you found it helpful, and check out our other related videos for more learning. Subscribe to ReddyControls and hit the bell icon so you never miss an update. Thanks for watching.